In this particular video, we are going to be talking about momentum, impulse, collision, and Newton's law of motion. Talking about momentum, it is represented as P, and it is the product of mass and velocity. So our momentum equals m times v, mass times velocity. The unit of momentum is kilogram meter per second. It is a vector quantity. Then you have to know that change in momentum is final momentum minus initial momentum. The formula for final momentum is mv, initial momentum is mu. So your change in momentum is equal to mv minus u. We have impulse. Impulse represented as I. It is the product of force and time. So therefore, I impulse is equal to force times time. And the unit is Newton second. It's also a vector quantity. Impulse can also be defined as the change in momentum. So this simply means that my I impulse can equal to change in momentum. So therefore, impulse is equal to mv minus u. So that is what we have to know about what impulse and momentum. We have what we know as Newton's law of motion. Talking about the Newton's law of motion, we have three. We have the first law, we have the second law, we have the third law. So let's talk about the first law, Newton's first law of motion. It states that every body or object continues in a state of rest or uniform motion unless acted upon by an external force. So this Newton's law of motion, the first law, explains the idea of what? Inertia. And this inertia is the quantity of what? Mass. Inertia is defined as the ability of the body to remain at rest or in uniform motion when acted upon by an what? External force. We also have what we refer to as the Newton's second law of motion. This states that the time rate of change in momentum is directly proportional to the applied force. The time rate of change in momentum is equal to what? Applied force. And this Newton's second law of motion can be represented mathematically as F equals mv minus u over t. Or we say F is equals to what? ma. Because this a is acceleration and it equals v minus u over t. And the third law of Newton's law of motion states that action and reaction are equal and what? Opposite. Then let's talk about collision. Guys, let's talk about collision. Talking about collision in physics, that is the process by which two or more bodies hit one another with great force. We have the types of collision, we have the elastic collision. So these are the stuffs we have to understand about the elastic collision. The first one is that the colliding bodies bounces off. In elastic collision, colliding bodies bounces off. And after the collision, the colliding bodies move with different velocity. And also, in elastic collision, you have to know that both momentum and kinetic energy are conserved. In elastic collision, both momentum and kinetic energy are conserved. And also, since both momentum and kinetic energy are conserved, so from the principle of conservation of linear momentum, m1mu1 plus m2u2 equals what? m1v1 plus m2v2. We have the inelastic collision. In inelastic collision, colliding bodies stick together after collision. So when they bounces off, it is elastic. But when they stick together, it is what? Inelastic. They move with the same velocities after collision. Since they stick together after collision, they will also move with what? Same velocities after collision. Then you have to know that for inelastic collision, only momentum is conserved. Only momentum is conserved. Kinetic energy is not conserved because it decreases. So you have to know that for the inelastic collision, when they stick together, move with the same velocity after collision, the formula, the equation is going to be m1u1 plus m2u2 is equal to m1 plus m2 times v. So this v is a common velocity. So you have to note that the principle of conservation of linear momentum states that momentum before collision equal momentum what? After collision. So that is m1u1 plus m2u2 is equal to what? m1v1 plus m2v2. Also, you have to know that the impulse and momentum, they have the same what? Units. So the unit of impulse is the same as the what? Momentum. And also you have to know that in all type of collision, momentum is always conserved. So let's look at some example, guys. The first example we are going to be talking about is this. A body of mass, the mass is 5 kg, moving with the velocity v is 10 meters per second, is acted upon by a force F is 25 Newton, and for 0.2 seconds t 0.2 seconds. Find the final velocity. We are looking for the v. So with the parameters given to me, so this velocity is the initial velocity. I have to remember the formula as f is equals to m v minus u over t. So this can be ft is equals to m v minus u. If I substitute parameters, that will be 25 times 0.2 is equals to 5 v minus u. So I can double side by 5. This returns to 25 times 0.2 over 5 equals v minus u. Since my u is 10, that is v minus 10. So therefore, guys, 5 here 1, 5 here 5. So this will be what? 1 is equals to v minus 10. Then v is equals to 11 meters per second. The next example I have there is that a gun of mass 10 kg releases a bullet. So solution. You have to note this. For gun speed of recoil, for gun speed of recoil, mass of gun, velocity of gun equals mass of bullet times velocity of bullets. Since I'm looking for the gun recoil speed, so that's when I'm looking for the speed of gun, Vg. So my Vg is going to be mb Vb over mg. So my mb, that is the mass of bullet. They say a gun of mass, so my mg is 10 kg. 10 kg. Released a bullet of mass 20 gram. My mass of bullets is 20 gram. I will convert it to kilogram by dividing it by what? By 1000. So that would be 20 divided by 1000. That is 0.02 kg. That is the mass of the bullets. At the speed of, so the mass of the velocity, this velocity is for the velocity of the bullets. Vb is 100 meters per second. Find the gun recoil speed. So I'm looking for velocity of gun, Vg. So this is the formula for my Vg from this formula. Vg is equal to the mass of bullets. The mass of bullets, that is 0.02 times velocity of bullets. The velocity of bullet, that is 100 over the mass of gun. The mass of gun is 10. This cancel this, and the answer is 0.2 meters per second. Next example I have here is that a 5 kg mass moving in the plus x direction. So it's this detail given to me. I have to be able to identify the following. If it goes up, that is plus. If it comes down, that is minus. If it is to the right, that is plus. To the left is minus. How to understand that? So they say a mass, a 5 kg mass, this is the mass, 5 kg, moves in the plus x direction. That simply means it moves like this. At 30 meters per second, 30 meters per second. Collides head on with another body object of 2 kg mass. 2 kg mass moving at 50 meters per second in the minus x direction. That one is moving like this. That is 50 meters per second. So it is moving in the minus x direction. So that's means that the velocity is negative because it is moving in the negative direction, minus x direction. If the bodies stick together, if they stick together, that simply means after the collision, they stick together. 5 kg. Find their common velocity. So I'm looking for v now. So since they stick together, I just have to remember the formula. M1 U1 plus M2 U2 is equals to M1 plus M2 times V. So whenever you see two bodies stick together, this is the formula you're going to be using, the equation. So my M1 is 5, my U1 is 30, plus my M2 is 2, my U2 is minus 50, is equals to 5 plus 2 times 7. This is 150 minus 100. Because 2 times minus 50 is minus 100. Plus plus is what? Minus 100 is equals to 7v. So this is 50 is equals to 7V. Then if you press 5, 50 divided by 7 on the calculator, your V is 7.143 meter per second. Last example for this particular video is calculate the velocity of a body. So I'm looking for the velocity B. Having mass 9 kg, the mass is 9 kg. Linear momentum, my momentum rho, 63 kilogram meter per second. So I'm just remember that my momentum rho is mv. 63 is equals to 9v. V is equals to 63 divided by that. That gives me 7. That is 7 meter per second. So thank you for watching. See you in our next video.